We are now recording.
Awesome.
Episode 3 of Everybody's Podcast. It's been a week. I was out of town for a lot of it.
Yep.
We are now up to 19 subscribers as of today. We have, as of last night, 16,000 views and 100 hours of watch time.
That's amazing.
Not bad for 2 weeks' work.
Yeah. And thank you to all of you that have spent the time to watch our content.
We really appreciate it. And we're having the time of our life and hope you are too. Some technical changes. We could not get the video follows audio on the OC Stream Deck to work consistently. We got it to work really well a couple of times, but we needed something that would work consistently. So we've now changed over to an ATEM Mini Pro ISO. Significantly more expensive than the OC Go Stream Deck. The OC Go Stream Deck was $295. This one was $550. There are upsides and downsides to both, but this deck records all channels at once.
Right. And one of the issues we were having was that the USB bandwidth split between even two computers was too much for us to record all 4 inputs at once. The one with the VFA and then camera 1, 2, and 3.
Right.
All at the same time and have a usable video. Since the ATEM records all 4 at once, we can do video follows audio in post much easier. And for the most part, the video follows audio out of this deck should be okay. Or does it not have it?
So this deck does not have video follows audio.
It does not have it. Okay.
But another reason I wasn't hesitant to buy this deck is because it's owned by Blackmagic, which also is the publisher of DaVinci Resolve. And DaVinci Resolve Studio has its own auto switching. So it can do video follows audio, cuts and edits from DaVinci Resolve Studio.
In post. Okay.
In post, yeah. And when I tested it, it did it well. Hopefully it does it well for this.
Oh, yeah.
Yeah.
Hopefully, because we don't want to go through another Stream Deck.
So there is another alternative, which is to buy an iPad, and then there's software specifically for the ATEM Mini, and it has video follows audio.
Okay.
From what I've seen, that video follows audio feature works very well, but that would basically be another $500 for the iPad and another $50
for the app.
Yes.
Okay.
Hopefully, just with what we have, we'll be able to keep it going. So, are you ready to look at some comments since our last episode? Here is our first comment. I am your first YouTube supporter. Remember me. This is the first comment on one of our full-length episodes that we posted to YouTube.
And who is it?
From 40 Zips.
40 Zips.
5 days ago. What do you think?
Welcome to the fold, my friend.
We appreciate it. Thank you. And we will remember you. All right. Mark 9237 on the clip where I'm talking about dark matter rivers that go through the universe. A lot of brain dead yapping for absolutely no reason. Yap Fire 100.
Awesome. We appreciate the feedback.
Well, I don't know. Is there for no reason?
It's the same as any other existence.
Firewater by Design on the same video said reptilian. So this one kind of threw me off a little, and it has a green duck emoji next to it. Threw me off a little. It could be that she's saying that I have a reptile brain, or that you're reptile brained. Basically, you just pinball from one emotion to another. Your decision making is a series of emotional responses without any mitigating thought.
Okay.
It could also be referring to the reptilian aliens.
Yeah.
You know what I'm talking about.
Yeah, yeah, she could also be calling us reptilian, in
Yeah.
the sense of one of those aliens.
One of the aliens who
We're
runs
from the
the
deep state to
world. Right.
to influence your thinking and
I had somebody tell me that she was sure Bill Gates was an alien.
mm, well,
You see, here's the thing. A lot of people, when they're around people who are CEOs or legislators or whatever, the image those people project, and they do it with help from a lot of people in marketing and PR and everything else. And the image they project is that they're somehow above everybody else, right? That obviously, if you're going to be the CEO of a company, you want the shareholders and everybody else to believe that you are just not a normal person, right?
okay,
But once you've been in a room with folks like that and you've talked to them, right,
you kind of break through the veil.
right, and then it becomes pretty obvious that they're just regular people
Yeah,
like
another
everybody else, and
right.
they gotta ride in the same elevator and shit in the same toilet and pay the same fucked up rates to Comcast and the gas company as everybody else. And then you realize they're, I mean, I don't want to say there's nothing special about anybody, but you realize these are just people like
Right.
everybody else. And it should be the same even if you were in the room with the president or Bill Gates or anyone else. Once the facade, the public facade that they have to maintain, the dissimulation they have to put out there for public consumption, once you saw through that, you would see this as just a normal person.
Right.
The thing is that just saying that these are all just regular people
Right.
who think regular thoughts and make regular mistakes, that doesn't sell.
Yeah, that's true.
The conspiracy theories sell.
Mm,
Yeah.
okay.
Anyway, this next pair of comments is on the clip I had talking about Albert Einstein and his wife, and how it was kind of an open secret that his wife helped write his his most important papers, his most revolutionary papers that were written early in his career, were actually a collaboration between him and his first wife. And one said, "That's actually crazy. I didn't know that." Hey, I'm Red 2745. Thank you. I'm glad I could share some information with you. Chris Bartand, 8,400 feet, said, "I hate unsupported assertion. The dead giveaway was his stating it was an open secret." Translation, there is no evidence to support.
Okay.
What do you think?
Usually, almost always, people cannot develop those kinds of massive frameworks on their own,
Yeah,
massive discoveries on their own.
agreed. Yeah. And I'm not the only one who believes that she helped write those papers.
Right.
And actually, one problem that we have is that at that time, one problem we have still today is that very often people do work for others that goes into scientific papers and scientific research, and they're never given credit.
Right.
And so there's no evidence to support. I'm going to have to disagree. The evidence is circumstantial,
Okay.
and to me, it's convincing. But Chris Bartand, I respect your position.
And you mentioning that the evidence is circumstantial, even in like criminal cases, a lot of evidence that gets people convicted within a shadow of a doubt is circumstantial.
Mm, yeah, that's true.
Leaving leaving the scene of a crime at the exact moment it was committed is circumstantial evidence, but that is something that gets people convicted.
Sure.
The only thing that makes it actual hard evidence
Uh-huh.
is things like DNA, fingerprints, weapons, physical items,
Right.
pictures, stuff like that. Circumstantial is everything surrounding that.
Yeah, that's true.
So oftentimes circumstantial it can be even more convincing
Well,
in a legal setting.
the circumstantial evidence is things like same place, same time.
Right.
They had a beef with each other. This person went and scoped out this other person's house. Since we're selling this house, no, there have been cases where people went to open houses,
Okay.
cased out what people had.
Oh yeah,
They
and
went
then
burglarized it later.
and the one thing in this house that people could steal is that TV downstairs, and we wouldn't even be.
We don't even watch it.
Yeah, we don't even use it. I haven't turned it on.
There's just too much to do. There's just so many things to do. Then sit there and watch TV or scroll social media. It all feels like a waste of time to me to do that. Next comment.
Yeah.
Wired versus wireless cameras, latency and reliability explained. Flaxnor said wireless cameras can be blocked with a signal jammer, so a bad choice. Wired cameras with a DVR and cloud storage is the way to go. So we weren't really, I think he's looking at a different context than we were talking about. We were talking about in the context of doing our podcast.
We don't use any of these for surveillance on our house or anything.
I think he was talking in terms of surveillance.
Yeah, like protecting your home.
Have you ever heard of wireless cameras being blocked with a signal jammer?
It's foreseeable. It's certainly plausible.
It makes sense to me, but I've never seen it done.
So Bluetooth is incredibly unsecure. Bluetooth's really easy to. You can look at. Bluetooth isn't private. Anyone can access what you're broadcasting on Bluetooth.
So when you're connected to a Bluetooth device,
all the other devices around you can actually see and interpret what's being sent.
So what's the point of the connection?
The point of the connection is wireless connection, but it's just not secure. So you can make sense to do it for music, videos, anything you don't need to be secure.
So don't use Bluetooth for anything that should be secure.
Right. And then radio signals as well. If it's based through 2.4 gigahertz or anything like that, or Wi-Fi, all of those can be jammed.
Huh.
Yeah. Okay. Every one of those is based on light. All you got to do is...
Yeah, it's microwaves, yeah.
Is make a brighter light, and then that signal is lost.
Huh.
But obviously, if it's not the exact frequency, it's just going to pass right through, right? Okay. And you'll still be able to detect it. For the best terms of anti-jamming is fiber optic. So if you're really concerned about jamming,
run the cable to the router.
Run it through fiber optic connection.
And I imagine if you're talking about high security installations, that's what everything would be.
Maybe. I have no idea. I just know that's how they prevent drones from suffering EMPs. When forward attacking drones is that use fiber optic.
Oh yeah. You mean in the trenches in Russia and Ukraine?
Yeah. You got to use.
I guess
they're probably not that sophisticated out there.
Scary what's going on there, dude. I mean, it's basically trench warfare with drones being the artillery. Like it's smart artillery.
Yeah. And what was it? Was it a couple of U.S. students that figured out?
They developed a machine learning algorithm that the drones could then use to go target on their own.
Right. Once it was a guarantee that radio signals were jammed.
Yeah.
They're a long tangent, man.
True. The jamming has become the name of the game too, in that, because what Russia started doing was taking all these old bombs they had in storage and putting wings on them so they could be gliders. And then the next step after that was adding a remote control so you could steer them. And what they do is they drop these gliding bombs, these aviation bombs. They could drop them from 40, 60, 80 kilometers away from a plane high up. And the reason they were doing that is because the Ukrainians kept shooting their planes down. So they started dropping these bombs from way, way out. And they would use them as kind of an inaccurate, not a very accurate type of artillery. But the thing is, they're slow flying. So what the Ukrainians started doing was sending drones high up to jam the signals, and then using an AA gun on a pickup truck
Oh,
to shoot down the bomb.
those guide bombs, they are not a new idea at all. US has been doing it for, I think, over 30 years.
Dark matter unveiling the universe's invisible web. Blurg Joka 3116 says, where did this dark matter come from? All this coming from nothing makes no sense. Any scientific explanation? Otherwise, God did it.
Gotcha.
What are your thoughts?
My thoughts? I don't know what the scientific explanation is.
There really isn't. There's a lot of conjecture,
Okay.
but there's no
Hard-founded evidence.
right.
Okay.
So there's just a number of hypotheses for where it could have come from, or what it even could be made of. Nobody even knows what it's made of.
Right.
So as far as scientific explanations, there's a lot of them, but there's no scientific consensus.
I've heard, how can genetics exist without the existence of God?
Mm-hmm.
Things like that. How can life exist without the existence of God? And you can harmonize your faith with the secular.
That's what I do.
And because science and all these ideas, you can interpret it as just the paper that God writes his ideas down on, or the method of applying his vision to the universe.
So to say otherwise God did it, you're saying God did it either way. To me, and this is a more of an emotional experience than it's not something I can just describe or give evidence for, and people go, oh yeah, yeah, yeah. For me, there's no separation between the physical and the numinous, between the mundane world and the spiritual world. My spiritual belief can best be described as panentheism, which is the idea that divinity pervades, and it's the idea that divinity both pervades and goes beyond our universe. To me, like studying science and thinking about science and growing spiritually, and I shouldn't just say studying science, studying art and history and humanity and nature. To me, it's growing in that way is the same as growing spiritually. There's no separation, in my opinion. What do you think?
I like your view on it. But yeah, I've had plenty of really Christian friends who are, they still believe in, they don't really separate God from science. They believe that God is the science, and that science is the way that God has written it down.
Do you think most people actually see it that way? Do you think most people have no trouble merging the two? There was one other comment I saw that said, gummies keep them off the streets. And it was one of the space ones where we were talking about space. And the comment was, gummies keep them off the streets. And I assumed the person was talking about us.
Gummies?
I'm assuming THC.
I have,
Gummies keep them off the streets.
I don't understand the comment.
Well, in answer to it, I don't
Yeah, I don't
take any.
consume.
This is a de-alcoholized wine, St. Regis de-alcoholized Cabernet Sauvignon. So I don't even,
Right.
yeah, no alcohol, no nicotine.
The only drugs I consume are caffeine.
Sure. Yeah. I guess I drink cacao, and cacao contains theobromide, which is a very mild stimulant, mild compared to caffeine. So yeah, we're basically drug free over here. But I don't know. I guess if we took gummies, it would keep us off the streets.
Yeah, maybe he sees us as contained.
Right. So we were talking about becoming who you are.
Okay.
Right. Nietzsche.
Mm-hmm.
Becoming who you are and what that means. Well, so one of Nietzsche's, well, probably his best known line is that he said, God is dead, right?
Yeah.
And the line actually
Is it
begins,
Friedrich Nietzsche?
Friedrich Nietzsche. Yeah.
Okay.
And what he said, it's a aphorism in the gay science, where he says, did you hear about the madman who went out in the marketplace screaming, God is dead and we have killed him? But it wasn't celebration or a statement of news that he was putting out there. It was a lament that God is dead and we have killed him. And what Nietzsche explains later on in Thus Spake Zarathustra is that with evolution, with evolution by natural selection, as it was laid out by Charles Darwin, and I should say it wasn't an original idea from Charles Darwin, but what, if you ever read his book on evolution by natural selection, by means of natural selection, he basically lays out this case where he talks about species, different species from all over the world, different ecosystems from all over the world. It's hundreds of pages where he just lays out this argument about the similarities and dissimilarities between them and their next closest, the species that's next closest to them. And he makes this case that it's just by natural selection over thousands and millions of years that you have all this differentiation within ecosystems. And what Nietzsche was saying was that with that, as knowing that natural selection, evolution by natural selection, is how humans came to exist on this planet. We can no longer look to an idea of God as the unknowable creator of things, that we weren't just established through magic by a person, by a deity that is a person. And so we can no longer rely on those same religious traditions that gave us that deity. We can't rely on them for moral guidance either.
Okay.
We have to create our own morality, our own moral systems. And so a lot of his work was wrestling with, how do you do that? How do you chuck out these traditions without chucking out, basically, you could almost say, how do you not throw the baby out with the bathwater?
Okay.
How do you keep moral systems that keep people safe and keep people growing?
Well, I have a pretty good example of those systems agreeing with each other. And when someone becomes addicted to a substance and they decide within themselves they can no longer live this way, and they go into, say, 12-step program. The 12-step program tells you to give your addiction unto God
Okay.
and to basically say you are powerless to this addiction, and the only person who can help you through it is God, get you to the other side of it. The thing is that with prayer and with meditation, they activate the same level of neuroplasticity in your brain that allows you to overcome addictions like that.
So wait, prayer and meditation activate neuroplasticity.
Yes. So when you pray to your God and you ask him to take away your anger, in your brain physically changes. When you ask him to take away these burdens, your brain enters this level of neuroplasticity that it does not have throughout the rest of the day. And whether you see that from a religious standpoint or not, there are two approaches to reach that neuroplasticity. You can either pray or enter deep meditation. And for a lot of people, the method of prayer is a lot easier than achieving that deep meditation, but it has to be just as genuine, just as your commitment to it has to be just as much.
I was going to say, it seems like prayer would be more accessible.
Prayer is more accessible for more people. And to converge those ideas, when you say, I cannot get through this addiction, I must, on my own, I must give it unto God. You can converge those ideas and say, I am not bigger than this if I do not treat this like my number one priority, my full-time job, my morning, noon, and night. I am going to lose this battle. Once addicts end up on the street, 98% of the time they die from some cause from their addiction, whether it's exposure from being homeless, starvation, murder, suicide, all those things that stem from their addiction. They have a 2% chance of escaping it. And for most people, the best way that they get through it is by giving that addiction unto God. But first, they must say to themselves, I no longer want to live this way. I cannot. And they must be more willing to die than to continue living this way.
That's actually an interesting irony that you have to say, I would rather get clean and stay clean even if it kills me. And in the process, you
It
actually
saves
save
them.
your own life.
One person I really love is Coach Kelly on
Okay.
Instagram. He is a former crack addict. He basically says all the same stuff.
Interesting. One thought experiment Nietzsche proposed for how do you create your own morality? How do you create a moral life? Is he said, imagine that you had to take the life you're living and relive it again and again and again, forever. The decisions you make today and made yesterday. Can you relive it again and again forever if you had to? And be happy with it. Say, this is the best possible life that I could live. And he gives that the idea of eternal recurrence. And it's something that in human thought, historical human thought, that isn't such an unusual thought. You could say the idea of reincarnation is the idea that you come back again and again. You could even say, like, the Christian idea of heaven and hell is that if you go to hell, you are forever condemned and you have nothing to do but relive your mistakes. And if you go to heaven, you have nothing to do but relive all the things you did. And what one interesting aspect of reincarnation to me is you're basically saying, if you don't try to make the world a better place now, you're going to be born again into the world that you helped create. So if you ain't trying to make this world better, you're going to be born into a world that's worse.
That you made worse.
Right.
Bought and paid for. Oh, yeah.
Yeah. That it actually kind of brings on this cosmological question to me. So you could say, if time goes on infinitely, and you could even say, how far back does time stretch? Is it primary to this universe? Is it a primary attribute of the universe, or is it an emergent property of everything else? Right.
Okay.
And there's conjecture about both. I tend to fall on the side that it's an emergent property, that it's a result of our perception and interactions. But you could just as easily argue that time is it is one of the primary attributes of our universe. But if you were to take time and say it goes on and on forever, then everything that's thermodynamically possible would have to happen.
Okay.
And it would have to happen again and again and again.
Right.
So then you have to say, what's thermodynamically possible? Is there a limit to thermodynamic possibilities, right? Which then you'd say, okay, so if they're limited and time is infinite, then not only does it happen, it has everything that can happen, not only happens, but it happens an infinite number of times.
Okay.
That makes sense so far, right?
Yes.
The alternative is to say there's actually an infinite number of thermodynamic possibilities. And then the question is, which grows faster, time or possible existences, right? So if you said, yes, there will be an infinite number of thermodynamic configurations and possibilities, right? But that the rate at which things become possible is half as fast as time passes by, right? Then you'd say time divided by possibilities is 2. So everything that can happen would happen an average of 2 times,
Okay.
right? So that would mean, though, that some things would actually never happen
Right. And some things would happen.
a lot.
Yeah.
So you'd actually have like this distribution of how often something that's possible happens. But then you could use that distribution to say things are more or less likely than others.
Okay.
Have you ever heard of the 3 hairs?
Like rabbits?
Yeah.
No. Are you passing me the pewter?
Yeah. It's an optical illusion. What do you notice about that?
It seems 3 identical hairs moving in a spiral. Oh, but the ears, there's only 3 ears, but each individual rabbit has 2.
Right. So it's an optical illusion. That is from a church in Germany. That image there is from Wikipedia, from a medieval church in Germany. So it's on a Christian building. But what does that have to do with Christianity? Keep it open.
The 3 hairs?
Yeah. The 3 hairs, this is where it first shows up, is in the Mogao Caves in China. I have it marked. There's a map on there where it's marked. And go,
Yep.
Yeah, I believe I can't remember exactly where it is, but it's northern part of China, close to Mongolia, just north of all the mountains.
Yep.
And there's just tons of different religious statues and mosaics and carvings in these caves. I would love to go visit them. These are some of the earliest depictions. And you can see, these are all from those caves. And they're all from between 581 and 618 AD.
Yep.
And we have no idea what
sparked it? Why?
Yeah. But when the Mongolians took over everything from Mongolia all the way out to Hungary, Eastern China, the Middle East, right? When the Mongolians did that, they created this trade route called the Silk Road that went all the way from Constantinople to modern day China, right? And it was called the Silk Road because that was what got traded along. It was silk. And as a result, all along that Silk Road, there are depictions of the 3. If you go to the next, that is from a plate, a Persian plate from medieval times. And you can see it's extremely ornate, but it's the same thing. And there's a whole lot of religious significance that's assigned to it by different religions, by different mythologies and different traditions, assign different meaning to it. Some say it represents the cycle of life, death, and rebirth.
Okay.
So, because they're all following each other in this eternal circle, right? In Christianity, it was said to represent the Holy Trinity, the Father, the Son, and the Holy Spirit. Others have said it represents the Holy Family, so Mary, Joseph, and Jesus, right? Go to the next. In medieval churches, I believe this one is from England, you have the 3 hairs juxtaposed to the green man. The green man was covered with foliage.
Oh, okay.
And people would say, well, the green man represents the verdancy of the earth, and hairs are a fertility symbol. In fact, hairs were for a long time, they were thought to be born pregnant. They were like the tribbles in Star Trek. I don't know. Have you ever seen the Star Trek episode, The Trouble with Tribbles? The tribbles are these cute little fluffy, no face things, and they're cute and they're nice, but they just keep on reproducing. Like if they have food, they just produce more and more.
Okay.
And,
So like bacteria.
right. And Dr. McCoy says these things are practically born pregnant. They basically get into the ship's grain store. They eat the grain stores. And so finally, to get rid of them, they beam them onto a Klingon ship. But yeah, hares were thought for a long time to reproduce asexually, like they could just pop out more hairs all the time. There's no contemporary source to really tell you exactly what this symbol represents. Something different to everyone, almost.
Well, I mean, it's a cool design.
Yes. Oh, it is. Yeah.
Yeah. You assign whatever meaning you want to it. It's just cool.
There are versions of it that have 4 hairs.
Okay.
The words I put on that, those are references to the blog pages I found those on. What that etching there shows is from the Golden Legend.
My bad.
The Golden Legend, which was written by Jacobus something or other. Jacobus of some village somewhere.
Yeah.
And he compiled the Golden Legend, and actually a lot of medieval writings, medieval stories are actually compilations of legends. If you ever read Parzival or the Arthurian legends or anything like that, they're written by somebody. And these people were all doing it by quill or by twig, dip in ink. And then the way their stories would get spread is somebody else copies them. And at a time when the literacy rate was somewhere around 4 or 5% of the population. So it wasn't like people could just sit there and read. You'd have to go somewhere to a church or gathering of some kind where there was someone who could read, and they would read the story to maybe to you, probably to a whole crowd of people.
Right.
And you would actually kind of pay them
Yeah.
for their trouble.
What is it in church?
The collection plate.
Yeah, it goes around.
Right. And that's what bards were. Very often they would tell these stories and they'd be told to music. And if you look at the Homeric legends, the Homeric myths, people would memorize the whole thing, and they would memorize it to a beat. And someone would sit there in the amphitheater and ping out a beat
Okay.
while the person repeated it. The writers of these legends in medieval times, because it would take so long to write something, they usually had a noble person who was their patron.
Okay. Someone who put them up
Right.
while they wrote.
Yeah. This guy, Jacobus, he was a friar. So we have to assume
Okay.
the church was paying him somehow. He may have just lived in a monastery and his whole job was to write this stuff. But
Yeah, if he was a friar, that's what I would assume.
right. So in this particular engraving, he has the life of Adam, the first man. He says a story, and it isn't really well sourced, but here's how it goes. Adam, the first man, he lived 930 years. And before he died, he told his son Seth to go to heaven and get the oil of mercy, right? And the assumption is so he can be anointed and his sins purified, anointed with the oil of mercy, and his sins are purified, and then he can go up to heaven.
Okay.
And Seth goes up to heaven, he gets the oil of mercy, and he also gets 3 seeds from the tree of life. And he comes back down and says to it, the angel gives him the oil of mercy, that's what I should say, along with 3 seeds from the tree of life. So you have 3, right? You have another
Trinity.
right.
Yes.
You have another occurrence of 3. And he comes back down and he says to Adam, hey, listen, the tree gave me these things. The angel gave me these things. And Adam laughs and then he dies. Seth pours the oil down his throat and puts the 3 seeds in his mouth. And out of his mouth, those 3 seeds grow into 3 trees, which then become part of the cross on which Jesus was crucified. They become the cross that Jesus was crucified on, which kind of throws me off because a cross of 2 boards.
Yeah.
So I guess you could say maybe there was something to hold his feet up or what? I don't know.
Hmm.
You could say maybe it's the board on top, the board that says INRI that made the sign. That would be the third tree. So you have this whole thing where Adam is the green man, and three sprouts from the tree of life come from his mouth. The first man becomes the tree of life. And the tree of life creates the cross that gives everyone the route to eternal life.
Okay.
So you get that same idea of eternal recurrence within the green man legend, kind of folded into this Christian legend, this biblical legend. So that's actually the guy who wrote this blog, that was his conjecture, is that that's why you see the green man in all these churches. And it would make sense then that you could juxtapose it with the three hairs,
Okay.
that it's symbolism, it's iconography that fits. Obviously, it's mythological iconography. It's not originally Christian iconography, but it works its way into the Christian religion through, I guess you could say, extra dogmatic stories,
Okay.
which, in my opinion, are just as important as the dogmatic tales, because they allow people to relate to it themselves. I wanted to tell you about the three hairs.
I enjoyed the three hairs.
Yeah. So what are your thoughts?
On the three hairs. And
So it's your turn.
all right. This week,
Here,
I went ahead and
hand it over to you. Can control.
these are out of order.
Okay, I put them in out of order.
I have notes on my phone. I'm going to
Gonna use the phone? Okay.
look down at my phone.
Just don't let the computer fall off your lap, dude.
Okay. I wanted to tell you about the genetic history of cats. I wanted to tell you about the genealogy of cats.
Okay.
So, domesticated cats. They were first semi-domesticated when we first started building farms on the Fertile Crescent
Okay.
12,000 years ago.
Tell me about the Fertile Crescent.
The Fertile Crescent is right off of is it the Med?
Okay.
Is it the Med?
Yeah. Yeah, I believe so.
Basically, that's where we first started farming. That is the beginnings of where our civilization, like our no longer hunter-gathering lifestyles began, where it became these villages centered around bodies of water and farms. Immediately when we started building fields with full of food, grain, right?
Mm-hmm.
Mice were a problem.
So rodents have always been a problem for civilization.
Agriculture, yes.
A problem for agriculture.
In fact, in my studying for this, rats genetically followed this trend of essentially unintentional domestication by humans.
Really?
Yeah.
So rats and mice.
Yeah, mice. My bad.
Not rats?
Not necessarily rats. I didn't see.
Okay.
I only saw a specific call out for mice.
Okay. But it may very well include rats. It wouldn't surprise me if it did.
Yeah. So just as soon as we are beginning to cultivate the ground, right? We are semi-domesticating cats.
Mm-hmm.
We are using cats to manage rodent populations and protect fields of grain.
Hmm.
And the first cats that we are using are the African wild cats.
Okay. So would this then first be showing up in North Africa? If it's African wildcats, or
They are native to Africa and this Far East, I mean, not Far East, Near Eastern region.
well, okay, I can believe that because lions were actually common throughout Mesopotamia up until just like 1,500 years ago. They were a normal thing to have out there. It wasn't uncommon for people to be killed by them, and people would hunt them. So when you tell me cats, these African wildcats were spread
Right.
around there too, that makes sense.
Fs. libica.
Okay.
Libica. The first time that we actually began to hardcore domesticate cats was about 1,000 years after the formation of ancient Egypt.
Okay.
The first time that
So wait, the Egyptians were the first ones?
to truly domesticate them.
Okay.
And actually, the first time that someone was buried with their cat was 9,500 years ago in Cyprus.
Okay.
So for at least
9,500 years ago.
yes, yeah, it was someone was entombed with. They basically found a skeleton of a cat with them.
Hmm. Well, that's long before ancient Egypt.
Right. So there's some evidence that we were domesticating them. So the difference between a semi-domestication and a true domestication, at least in reference to cats, is how much we let them live inside,
Okay.
right? Obviously, a 100% indoor cat is a domesticated cat,
Okay.
and a 100% outside cat, right, like a barn cat or a mouser,
Hmm.
those are semi-domesticated, right? So
Yeah,
if,
it's probably nice enough to you when you come up to it, but it ain't living indoors.
yeah, it doesn't want to hang out with you.
Okay. I don't know. Some barn cats are mean as fuck, though, man.
Yeah, those are right.
Okay.
They're semi-domestication means human involvement, essentially.
Okay.
Let's see. So here on this graphic representation, it's just specifically speaking about the right side, right?
Okay. On the right.
Is this is a genetic map of centered around cats from the Near East, that Fertile Crescent.
Okay.
And what this graph shows us is that these cats from around the world, Africa, Asia, Australia, East Asia, the list goes on. Every domesticated cat that we have around the world come from the Near East region, or otherwise these North African wildcats. And what the researchers say is that in a delta K of 2, so in this graph, it goes from 0 to 2 and 0 to -2. A distance of 2 is a unique domesticated cat, genetically unique. And basically all
Wait,
domesticated cats.
a delta K of 2 then would be like its own breed? Is that
No, so these are, thank you for asking that question. These are random bred cats, so basically strays.
oh, okay.
Domesticated cats for particular pedigrees have only existed for about 200 years.
Oh, okay. Huh.
So Yam there, he's a Norwegian forest cat mixed with a random bred cat.
Yeah, with whatever came over the fence. Yeah.
Anyway, those particular pedigrees have only started to exist for about 200 years. And what's significant about this graph is that anything within a range of 2 is not genetically dissimilar from each other, not significantly genetically dissimilar. And what that shows actually is that it proves all cats come from the Fertile Crescent. That's where they originate from. Because almost none of these, there are some outliers that are over 2 from the center, but all of them are centered around cats from the Near East.
So even the outliers average out to being,
Pretty close.
huh? All like house
Domesticated.
cats.
Even though there are house cat sized cats
Hmm.
native to South America, in San Marcos, it is still cats from the Near East.
No way.
Yeah. Actually, something significant of note is that in the New World, North America, all the cats have genes from European wildcats. Reinforces that all the cats in North America came from colonization by the Europeans.
By Europeans. Man, that'd be hardcore bringing a cat across on a boat that
Mice were a
sailed over
problem.
recently. True. That's a good point. But I mean, I guess I have such an aversion to the smell of cat piss. Then again, so do mice. And I guess if you're out on a boat there and it's going to be humid anyway and there's no latrine, I mean,
You do your best.
I guess I guess all the other smells are going to be so overwhelming anyway, it may not matter.
Right. Hopefully, maybe they had figured out litter boxes by then. But yeah, maybe boxes of sand.
Yeah.
That's conceivable. Anyway, the reason for anyone studying and figuring out where cats came from and what they are genuinely is reason for the genotyping is so that people who have cats as pets can figure out how to take care of them better, have them live longer. Professor, looking at my notes here, Toru Miyazaki of the University of Tokyo. He has developed this vaccine, which some of you may have heard of, that is aimed at doubling the lifespan of cats.
Okay.
And it's a treatment for chronic kidney disease. In cats and in humans and all mammals is you have this chemical called AIM,
Okay.
which is the apoptosis inhibitor of macrophages.
Huh. Okay.
Is it a protein?
It would have to be. Well, okay. So macrophages are they're immune cells.
Well, this is something that
Acts on macrophages.
so the AIM protein, it
Good.
tells the macrophage not if that it is functioning to not kill itself.
That's pretty crazy. So its default is to kill itself unless this protein is present.
If it's damaged, it prevents it from committing apoptosis because when you split a cell, it releases a chemical that causes apoptosis that tells everything that is damaged around it to self-destruct. Well, this tells macrophages not to do that because there is some cleanup to do where there is injury.
Oh.
And it is carried by the main immunoglobulin IgM pentamer. This is a massive protein. It actually carries multiple instances of the AIM. You're muted right now. And in felines, basically the way that AIM gets carried around on IgM is through polar bonding. In cats, it's 1,000 times stronger of a bond than it is in human. So IgM pentamer is the main immunoglobulin that basically IgM pentamer is when you have a foreign body in your body, it sticks to it and it serves as a red flag to your immune system as, hey, come over and consume this. Come over, destroy and consume. But on this IgM pentamer, in these slots, you can carry things. And one of the things it carries is AIM, which is the anti-apoptosis. In humans, the AIM separates from the pentamer really easily. And what that means is when you have an acute kidney injury, some of the cells die, some of them don't. And the dead cells become debris that block your nephrons. Nephrons are tubules that allow waste to process out into your urine.
So those tubules get blocked by cellular debris.
And the AIM inside those nephrons, what it promotes the surrounding cells to do is to consume that debris and to get rid of that debris through urine.
Sure.
And there's a membrane between your blood and your nephrons, those tubules. And because in cats, the bond between IgM and AIM is 1,000 times stronger than it is in humans, that does not happen in their nephrons. And what Professor Miyazaki found was that without AIM, the cellular debris never leaves. And the way he found out was by fattening up mice and removing AIM in their kidneys, nothing was happening. Nothing was getting processed out.
Hmm.
And he got that suggestion when he was in, I believe it was somewhere in Texas. A doctor who studied cholesterol was, hey, try fattening up mice. The mice that you're studying on, fatten them up. And Professor Miyazaki he didn't think anything was going to happen, but he was at a stopping point. So out of desperation, he tried it. And then he found out what AIM does. And anyway, what Professor Miyazaki's vaccine is it's unbound AIM and flooding AIM into the cat's bloodstream. Because unbound AIM is what makes it into those nephrons.
Right. I see. And so that allows cellular debris then to clog up those nephrons.
Remove them. It promotes the cells around it to eat that debris and exit through the urine.
So what is happening in cats that leads to the kidney degeneration?
So basically, that debris is never removed. And it
Okay.
creates blockages and prevents them from being able to get waste products out of them through their urine.
And it's because of this higher affinity between AIM and
IgM.
IgM.
Yeah.
Okay. Interesting. Okay. So basically, their immune systems can't clear out the blockages in their kidney tubules.
As well as toxins in their bloodstream because they're blocked. Their kidneys eventually become useless. And basically, whether you use Professor Miyazaki's vaccine, whether you use it as a preventative measure or as a acute treatment, it is effective in extending the feline's life
Okay. So
and improving quality of life in felines that are suffering from chronic kidney disease.
So is that something that's available now? Or
So from what I read, it is unclear whether or not it is still in clinical trials or if it is something that is available within Japan.
okay. So it's not yet available globally.
Yeah, we don't have it.
Okay.
As far as I know, we don't have it yet.
We don't have it yet, but if it proves to be safe and effective in Japan.
Yeah, currently all evidence points to it not having any side effects whatsoever.
Really?
Yep.
So then the only question would be the cost of producing it.
Right.
Or the cost of, producing, marketing, and distributing it.
Right.
Which could actually be pretty high for a new pharmaceutical.
Yeah. Especially with a protein as complex as AIM.
Right. Because then it has to be made you have to make it biologically.
Yep.
And so then you're fermenting all these components.
Yep.
And then having to purify them. I can tell you with those pharmaceuticals like that, the purification is actually the most expensive and difficult step.
Gotcha.
Because what you need a substrate that has more affinity for the complete molecule, the complete bioactive molecule, than for all the little fragments and all the little other pieces. And you can capture all the little fragments, and then you get a tube that has that substrate all around it, and you push your solution through the tube, and then coming out the other side, you either get fragments or you get the purified molecule. But just developing that substrate, and you're going to have to push it through at a specific rate, temperature, pressure. You have to get these perfect conditions in order to get your pure form of your pharmaceutical. And that's actually what makes the process so incredibly time-consuming and expensive, is that the separation is just so hard to do.
Right. Okay.
Now, a little bit about
Yeah,
the economic,
not something that I knew.
pharmaceutical production. Yeah.
So I imagine it will be probably a significant amount of time before that process is standardized for this particular application.
Dude, that's cool as hell.
Yeah, and all that is to say, all domesticated cats are genetically incredibly similar.
Huh. We'll have to see if, what's the professor's name?
Professor Miyazaki.
Okay. I'll send him an email. Tell him we talked about him.
Okay.
See if he wants to come and talk to us. We'll try.
She's in Japan, my friend.
That's okay. Well, hopefully he speaks English or has a friend who can, or
I believe he speaks English.
we can, if nothing else, we can get ChatGPT to give us English subtitles.
Okay.
There's 1,000 ways to skin that cat.
Another kind of footnote is that even though Professor Miyazaki, the reason why Professor Miyazaki actually cares so much about cats is A, he likes cats, and B, a friend of his that was who had a chronic disease really, he had a cat that he really loved.
Uh-huh.
And he kind of exposed Professor Miyazaki to this love of cats.
Huh.
And what Professor Miyazaki actually kind of hopes to do with this AIM research is not only it be applied to cats, but humans
Oh, okay.
suffering chronic kidney disease. And also, so
Well,
Professor Miyazaki is an immunologist,
right.
right?
Wow. That's actually, some people say that's actually the most complex subject.
So, yeah, well, I mean, he basically had no idea what exactly AIM did until something random just worked. And it's not random, but what I mean, it feels just as random as anything else when you're right.
Well, a lot of trying to figure things out scientifically is you throw a dart at the board and say, okay, we're going to examine this.
Right.
And see what we come up with.
Right. Yeah. Yeah, he's basically been on this for
Probably a couple
I think the article said 20 or 30 years.
Oh, yeah. Well, when you're talking about proteinomics,
Mhm.
that is just something that takes so long to, because you're looking at the specific reaction pathways, and this activates this, which activates this, and
Right.
you're not just talking about proteins, you're also talking about interacting with DNA and RNA. Just it becomes so complex, and tracing all those different pathways, and even identifying the proteins and what amino acids make them up and how they're folded. Like it just to find one pathway can take years.
Gotcha.
Yeah.
Hmm.
Dude,
Alright.
that was cool.
Okay.
Hey, don't close it up yet. Yeah.
What are your thoughts on
That was
domesticated cats, dude?
keep that. Keep
Oh, okay.
Hey, I actually had no idea that domesticated cats came from the Levant, from that Fertile Crescent area. I knew that in Egypt, cats were religious. They were almost angels. It was illegal in ancient Egypt because the whole trade economy of ancient Egypt was built on grain, because you could grow more grain in Egypt than in all the area around it combined. Egypt was this treasure. You've heard the jewel of the Nile.
Okay.
It was this treasure for the Romans and for you could say the Byzantines, but the Byzantines also considered themselves Romans. The Caliphate, when they took Egypt, because Egypt was the breadbasket of the Mediterranean, and you would feed entire civilizations just on the grain that came from Egypt. So in Egypt, the religion arose that cats were super sacred. And it makes a lot of sense because it only takes a few rodents to destroy your entire grain storage. You're impoverished.
The thing that makes them so valuable is that they're obligate carnivores. They won't eat the grain.
If it was dogs, they might eat the grain.
They won't eat the grain. That cat might eat the grain. Almost.
That's true.
But that's the difference
He's the
between
exception.
that's the difference between random bred and pedigree seeking
Okay.
domesticated lineages.
They lose the instincts that would have let them survive. There was a story I heard, or there's a story that's written in basically in hieroglyphics, about how a boy accidentally killed a cat, ran it over with his wagon, and basically the crowd,
Beat him to
people's
death.
justice, yeah, they did him in. They
Mm.
executed him for killing a cat. Killing a cat was a capital crime
Mm.
in ancient Egypt. That's how important they were. That they weren't just a fun thing to have around. They were critical to the survival of the society.
An economic asset. Not even just economic, though. That was survival.
Right. They were
Mm.
critical to the civilization and the state. Yeah. And not just that, but tons of people's livelihoods.
Right.
So, have you ever heard the term coyote ugly? Okay. There was a movie called Coyote Ugly. I think I had maybe heard it before, heard the term Coyote Ugly before the movie, but they talk about it in the movie. The movie is basically about a girl who wants to become, she's a songwriter and she's trying to get her song produced. The song is, it's not actually about the actual songwriter of this song. The song is Can't Fight the Moonlight, the song she's trying to sell. And in the movie, she successfully sells it. And in real life, it was successfully sold. It was like a #1 country hit, like in the early 2000s. Coyote Ugly is a bar, and she gets a job at the bar as a bartender. And it's just this crazy bar. All the bartenders are women, and they are just off the chain. One of them asked her, "What, you don't know what Coyote Ugly means?" And she's like, "What does it mean?" And she says, "Well, it's where you leave the bar with someone and you wake up with them in the morning, and they were beautiful when you went home
Okay.
with them, but you look over and
Yeah.
they're so, and they're laying on your arm, and they're so ugly that you don't want to wake them up, so you chew off your own arm." Coyotes will chew off their own leg to get out of the bear traps, and some coyote traps,
They ensnare the leg.
they bite the leg.
Coyotes are smart enough to chew off their own leg.
They will chew off their own leg to get out of the trap.
They are smart enough and driven enough. That is insane.
The thing is, when that trap is closed up for a long time, that flesh dies anyway. And once that flesh is dead, you can't feel it. So you would think it would be painful, but you actually feel it.
I was saying, I thought you were saying while it's fresh and maybe it's only been 12 hours.
I mean, think about it. If you had that thing clamped down on your leg, how long would it take for those nerves to be so overstimulated that you wouldn't even feel it? Because there was that guy who he was was he in Arches or was he in Zions? Where he basically got his arm stuck in a rock
Hmm.
and wound up cutting it off with a Swiss Army knife. But the interview I saw where he was talking about it, he said he actually couldn't feel it. Like the feeling was gone from that arm.
Just as
Well, as it turns out, bacteria do the same thing. So go to the next slide.
this is an African wildcat. This is a domesticated cat.
And they look the same.
They look almost exactly the same.
So you recognize that?
That is a phage,
It's
bacteriophage. It's basically a viral infection for bacteria.
Yeah. That is bacteriophage SP01. In this study I'm about to talk about, they looked at SP01 and SPP1. I went and got a picture of the other one, and they look almost exactly the same. Very quickly, if you want to go to the next, what phages do, they attach on, and you can see on there, it's multiple phages will attach to one bacteria, right? And every virus, when it attaches to a cell, it doesn't randomly attach. It has to find a specific receptor that the tip of its projector has been basically built for, right? And then it produces specific enzymes to open up that receptor, right? If you look at the case of COVID, what happens is the receptor attaches to the ACE, I believe it's to ACE2 receptor, and there are enzymes from the cell that saw off pieces of the spike and eventually allow the virus to inject its RNA, right?
So your own immune response.
Not immune response, but your cell's enzymatic machinery actually
Oh,
helps it to
okay.
enter, right? If it didn't help, it wouldn't enter. That's the same story here. It attaches to a specific site. I'm sure there's something enzymatic that happens, and it wouldn't surprise me if it's an enzyme within the bacterium that allows it to release.
So the representation I saw, I'm glad that you explained that because the representation that I saw made it look like the phages stab and inject.
Yeah, there's enzymatic assistance that leads them to do that. If you go to the next, so bacteria have developed a number of different defense mechanisms to try to stop that from happening. One is to block off the receptors that the phage would use. And the bacteria could do it because it's been attacked by that phage. It could also do it because other bacteria around it have been attacked by it and have released messenger chemicals. Say, hey, this thing's around and it's attacking us. Bacteria actually kind of communally fight viruses.
Well, any one on its own wouldn't be capable of preventing.
So yeah, anyone could be killed by them. Another thing they'll do is they'll try to block the injection itself from happening. So the phage attaches, but the bacteria inserts kind of a blocking enzyme that keeps the RNA from entering. There's another thing there. You see up on the upper right-hand corner, what it's doing is it's methylating all that phage RNA. It's attaching a lot of methyl groups to it, basically to inactivate it.
Mm.
So after the RNA is entered, the virus successfully did what it wanted to do.
Did its attack, yeah.
Right. But now the bacteria's machinery is trying to stop that RNA from ever being able to replicate. If you go to the next slide, have you ever heard of Cas CRISPR?
Yes.
What Cas does is it goes along and it tries to just recognize different strings of RNA or different strings of bases within the cytoplasm, within the bacteria. And it'll basically keep a copy of it. And what that protein can do is it goes along when a bacteria has been infected by a virus at some point. That Cas molecule, that Cas protein, will keep a copy of that invasive RNA. So it's almost like it's an immune system for the bacteria. And what it does is whenever it runs into a strand of RNA, it goes and the CRISPR gene envelops it and it checks all along it to see, oh, does it match this previous invader's RNA that came in? And as soon as it finds where it does, it just chops it.
Oh, that's awesome.
Right. Actually, that discovery that it did that, I believe it was in 2009. That's why it can be used to genetically modify cells, mammalian cells, is because you can use it to clip at any point within a strand of DNA or RNA, right?
Okay.
I believe what that other one shows is,
I did not know that CRISPR and Cas were something that naturally existed.
yeah, it's basically a bacterial immune system.
Hmm.
And another thing they'll do is they'll actually try to block, if all this hasn't worked, right? Last ditch. This is like the Hail Mary. It will have it. They have a bunch of proteins within the bacterial cell that can attach on to viral proteins they're being produced by the cell. So now the bacteria's machinery is being completely hijacked and it's producing these viral proteins, right? But it has other proteins that it already had sitting out there, like landmines.
Okay.
And what they'll do is they'll glom on to different parts of these viral proteins to try to keep them from actually forming the complete capsid.
Gotcha.
Then you got to assume the rest of it is somehow trying to fight to get its machinery back. It's kind of I may not be able to stop you, but I'm going to take you to hell with me.
I don't know. I don't know if you came upon this, but even with all these prevention methods, they're basically helpless to these phages.
Really?
Yeah. Yeah, that's actually C. diff is so prolific and it's so
Mm-hmm.
antibacterial resistant.
Yeah.
There are researchers working on using phages to,
Try to stop it.
developing phages that will,
The difficulty with phage therapy, it may very well work on C. diff because it's within your gut.
yeah,
Inside the gut contents itself, you don't have a whole lot of an active immune system. Your active immune system is just outside of that, right?
okay.
But part of the problem with phage therapy within the body is that your immune system also attacks the phages.
Well,
And your immune system will overcome them.
yeah. Well, they're not particularly compared to mammalian cells. They're not all that complex.
Oh, yeah, for sure. And they're not very good at masking their presence.
Hmm.
The thing when you talk about COVID, it's good at masking that it's even there. In fact, it deactivates your immune system a little bit. Within the first 3 days, it keeps your immune system from recognizing it. Part of the reason why COVID is able, when it gets a foothold, it usually has a strong foothold because it's had 3 days, it's had 72 hours to start replicating.
Hmm.
If you go to the next slide, there is a new mechanism that was found. Because of that, you can actually use phages to inject desired RNA into bacteria and have them start to produce the molecules you want them to produce. You can use phages. You basically take a phage, you remove its RNA, you put the RNA codes for the protein you want it to produce into the phage, you have the phage go basically put that in the bacteria. Now the bacteria is going to produce the protein you needed.
Hmm.
It's actually, you call it phage therapy. It's basically using a virus to help you get a bacteria to produce a therapeutic molecule. Yeah, super interesting.
Possibly AIM.
Possibly. I just wanted to point out for this next study I'm about to discuss, this is the molecule they used to actually put in RNA they desired, to put in RNA they desired into it, to basically create mutations within a population of bacteria. And they used it to create random mutation. Basically, it's a plasmid, which means it's a chunk of cell membrane that you can see it's circular. You'd put your desired molecule on the inside of it. And when that plasmid hits the cell membrane of the bacteria, it merges with it. And in the
Hmm.
process, it opens up and your desired molecule. If you go to the next slide, what they did, they took this bacteria, Bacillus subtilis, and it's actually a probiotic bacteria. It exists within your gut, which, and it's been studied for hundreds of years. Like E. coli, as soon as you had microscopes, some scientist was like, I want to look at my own shit under
The poop.
that. In fact, Escherichia coli it was named Escherichia coli. Coli is colon, and Escherichia is the guy who studied it. It's basically the bacteria from his own colon that he studied. Subtilis is used a lot because it's easy to mutate. It's easy to manipulate.
Okay.
It's been one of the most heavily studied bacteria, and it's used for other bacterial studies. And what they did was they mutated this specific gene, and you should see on there where it says delta YJBH. And then there's some green letters that say WT. WT is wild type, unmutated. And then that delta YJBH. That delta YJBH has had the YJBH gene obliterated from it.
Hmm.
There's a couple others on there, and I believe delta YJBH is in red. And then there's a couple of others on there where it's been manipulated, either been moved around or replicated on within the bacteria's genome. And that's in blue and yellow. And you can see the, I'll explain in a second. So what they did was they spread the Bacillus subtilis into Petri dishes. You can see that on the upper left. And then they infected it with SPO1,
Okay.
right? And you can see lesions on there. And the lesions on the wild type are very small compared to where YJBH was deleted.
Hmm.
And then there's another mutation of YJBH and then another. And you can see that yellow mutation appears to be better at fighting off the SPO1 than
Okay.
the wild type is. On the bottom, you can see, so in that middle band on the left, the image is red and green, or orange and green. It has both
Yeah.
orange and green. So that red is, they stained the bacteria that were delta YJBH. They stained them red. So the ones without the gene are stained red. The wild type is stained green. And they infected it. And you can see within a few hours, the red is dead.
Yeah, red's basically gone.
And then the green slowly starts to grow back over 16 hours. So the wild type made it. The red, with that gene deletion, it really didn't. And in the bottom left-hand corner, that shows how much was left after they injected it with 10-to-1 of SPO2 to the bacteria. So 10 times as much virus as bacteria was injected onto it. And you can see where it was at 10-to-1 on the lower right, the population of that delta YJBH group just,
Yeah, it died.
it just collapsed. And in fact, you only had 23% of it that survived. While with the others, with the wild type, it made it until it ran out of food. So you have this gene, YJBH, that is shown now to be a way that that communities of this bacteria fight off SPO1.
Hmm.
So then the question is how? How are they doing it?
Okay.
So go to the next. This is where they did it with SPP1. And they stained that YJBH protein. They stained it red. I believe that. I
Yeah.
believe that's it. Yeah, they stained it red. And then the blue stain is that other protein loci.
LACL, CFP.
And what this allowed them to do was see when the SPO was infecting these cells, or SPP1, when it was infecting these cells, it allowed them to see where that YJBH protein was going.
Okay.
And you can see it's focusing in on specific sites within the bacteria. And so there were specific sites where this YJBH was accumulating when they were infected with SPP1. Now, what would you expect? What else would you expect to find at those sites?
What do you mean?
Why would it be accumulating at those sites? Just give me your conjecture.
That's where YJBH is.
Why would YJBH be accumulating at a specific site?
To block.
It's doing something with that bacterial RNA. You would expect, well, that's got to be where the RNA is.
Okay.
And that the point of that blue is that that blue protein is believed to have something to do with how that RNA enters the cell and stays in it.
Okay.
Right? So go to the next. And what that shows, I'm sorry, go back. What that shows is that the red and the blue were accumulating together.
Okay. All right.
Okay. So what this shows, let me take a look here at what this shows. What it shows is that where you would have that YJBH accumulating, the cell would also start to divide. Right. So you have YJBH appears to be glomming onto the RNA, the invader RNA. And then the cell is starting to divide just above where it's at.
Hmm.
And I think if you go to the next slide, there's a video. Yeah, go ahead and hit play.
It's already playing.
Yeah. So you can see that it's basically cutting off the point where that,
Where the phage has infected it.
right. And it's just dividing. It's just dividing right there.
And presumably that portion will die.
Right.
Okay.
I don't know. I should have another image on. Oh, oops. We're out.
Spoilers.
Right. So that's what the cell is doing is
Sorry, dude.
YJBH is attaching on to this RNA, kind of glomming onto it, holding it in place. And then the cell is cutting off the limb, chewing off its own arm.
Yeah. Coyote ugly.
Yes. It went to bed with SPO1 virus and it woke up
Chewed off its own arm.
to get away.
Okay.
How do you like that?
I like that. All right. Are we going on to the brick?
You want to talk about the brick?
Do you want to talk about the brick?
Yeah, let's talk about the brick.
Okay.
That is Sagittarius pointing an arrow at the brick.
Okay.
So what I want to talk about is the molecular cloud, Sagittarius. I believe it's S2.
Okay.
Sagittarius S2. And I shouldn't say it's a molecular cloud. It's an entire structure with clouds in it.
Mm-hmm.
And the brick. And these are both located in the central molecular zone of the Milky Way.
What is the central molecular zone?
Go ahead and the next. So that's the Milky Way. That is the ESA's map, the European Space Agency's map of the Milky Way. In the center there, that's the CMZ, right? And if you go to the next slide, if you look toward the bottom of this version of the map, going toward the bottom from the center, you can see where the sun is.
Yep.
So the sun is about 27,000 light years away from the central molecular zone.
Okay.
And that central molecular zone, at first it was thought to be a small area, like 500 light years across, right?
Yeah.
500 light years across. Well, the Milky Way is 100 something thousand years across. I think it's more like 150,000 light years across. It keeps on getting bigger because we keep getting better and better at finding things
Oh, okay.
that are within the Milky Way's orbit. And if you want to talk about the dark matter halo of the Milky Way, it's so big that it extends all the way to the Andromeda galaxy, which is 2 million light years away.
It's coming this way, though.
Yeah, that's the thing is how do you define what a galaxy is? How do you define where it starts and ends? And that's kind of the problem you have with the central molecular zone is that central molecular zone, it contains basically the density of gas within it is just enormous compared to interstellar space. So if you were to take that central molecular zone, the gas density within it on average is about on the order of 10,000 molecules per cubic centimeter. To give an idea, on Earth, it's on the order of 10 to the 19 molecules per cubic centimeter.
Right.
So you have about 100 trillion times as much gas density on Earth as you do in the central molecular zone. But it's so dense compared to the interstellar medium. The thing is that you basically have clouds, molecular clouds within it that are up to 100 times, that can be hundreds of times as dense as
The average.
so even within the central molecular zone, what you have is clumps of dense gas and material. And then outside of it, it's much more diffuse. But some people say the central molecular zone, we can actually say it's the inner 40% of the galaxy
Okay.
because of how much activity goes on there. And you'll notice there's two bars within the central molecular zone. You see the football shape? If you look at it long ways, it looks like there's a couple bars coming out from the center.
Okay.
And those are
One going one way, one going the other.
yeah. So those galactic bars are where gas is coming in from the rest of the galaxy. It's getting sucked in like a vacuum cleaner
Interesting.
toward the center, and then it gets pushed back out from the center.
It's like the opposite of like a quasar.
Well, it kind of is what's going on with the quasar, though. It is a lot of materials getting pulled in, and then it's also getting pushed out.
Right. It just is, it looks the opposite.
Yes, it appears the opposite. So this image is the galaxy, what it would look like from above, like from galactic north.
Yeah, using the plane, like looking at it as if it were a disk.
Right. So you have from the horizontal plane materials getting sucked in, and then it would be getting pushed out through the vertical plane.
Okay.
Because if you were actually above this, our galaxy, it does obviously the black hole, our central black hole isn't super active, so it's not like spewing out all these X-rays and everything. But you would still be catching a fair amount of radiation if you were above galactic north.
No.
Right. So that central molecular zone, it's somewhere between 300 parsecs and 1900 parsecs.
What is a parsec again?
3.2 light years.
Okay.
Right. So go ahead to the next. So this is Spitzer's map of the CMZ, because we look at it from the side.
Yeah.
Right. The Spitzer Space Telescope was active from about 2003 to 2020.
Okay. Kind of a short lifespan for a telescope.
It did what it could. It was an infrared telescope, and it had two phases. It had a cold phase and cryogenic phase and a warm phase, right? So the cold phase is where it was being cryogenically cooled by, it had a canister of helium. And so that helium was being released into the telescope's lenses to keep them cold so they'd be more sensitive, right? And then after '09, it ran out of helium and it entered the warm phase of its service. It stayed active till 2020, mapping the universe. You see the bright spot SGRA star.
Yes.
That's the central black hole, and it's the thing is, our central black hole is surrounded by a massive number of stars.
Okay.
Tens of thousands, hundreds of thousands maybe, of stars that surround the black hole. And they're zipping around it at an incredible rate of speed, right? And they're cranking out all kinds of light and radiation across that whole CMZ. There's tons of other structures in there, but I don't have time to talk about all of them or memory enough to riff about all of them. But the two I'm going to discuss are the brick and SGR. Is it SGRS2?
Or SGRB2.
SGRB2. So if you go to the next slide, talking about the EM spectrum, we're looking at the near and mid infrared parts of it. So the near infrared spectrum is at 1.5 to 5 microns, and mid infrared goes from 5 to 25 microns. And that's the infrared spectrum. We're ignoring the rest of this. And a lot of that is because that CMZ has so much gas and dust in it that it's become opaque to visible light and to X-rays and everything else. They just can't get through, at least not through most of it. So infrared is actually what comes through the best. In fact, that previous image you saw was an infrared
Oh, really?
image, right? It was colorized, but those Spitzer images were all infrared. So if you go to the next slide, you can see the Milky Way. That's the Milky Way's bulge in visible light, right? But when you look at it, and it's setting over the Rocky Mountains, but when you look at it, you see lots of big black spaces.
Yes.
And that's the center of the galaxy. It should be super lit up. It should be super bright, but instead so much of it is occluded
Hmm.
by molecular clouds and shit like that.
Oh,
Yeah.
okay. So the infrared just passes through those molecular clouds.
Sort of. Not entirely. We'll get to that. That image there that's inlaid, that's a Hubble image
Hmm.
of the center of the galaxy. And you can see, even though it looks like a brightish spot, it's loaded with different structures and stars.
Yeah.
Yeah. So go ahead and go to the next.
The red giants were striking in that image.
Oh, yeah. Yeah. There's so much cool stuff. That central molecular zone it's the most active part of the galaxy. And it's so interesting. You could study it forever. The thing is, though, there's so much radiation there, so much gamma and X-ray radiation, that the chances you'll find anything living are so small,
Right.
right? And if you could actually trace those gamma rays that come out of there, you would see that they actually follow along the arms of the galaxy. Because what creates those galactic arms is magnetic fields within the galaxy, like we talked about with Mars or with Earth, where you have the magnetic field, where you have this convection current of basically conductive metal. You have this convection current of iron and nickel, and you have this initial seed of a magnetic field. And when that current starts moving, conductive metal starts to circulate, it creates an even stronger magnetic field, which creates an even stronger electrical field. And you keep going until it reaches equilibrium.
Mhm.
And that's the same as happens with galactic arms. You have all this gamma and X-ray radiation that's flying through these streams of dust. And that galactic dust, some of it is going to be ferromagnetic. Some of it's going to be iron or nickel or whatever it is. And so it creates a magnetic field. And that magnetic field builds on itself. And so you wind up with these arms of material. So you have arm, and then you have nothing, and then you have arm. Well, not nothing, but this is just another map that shows all these different objects within the CMZ. And if you want to go to the next, so this is obviously a blob.
Did you make this?
No. In the show notes, I have all the references.
Okay.
So I didn't include the references for this specific in this, but the show notes are going to be on the website. This particular part of our presentation is just the brick and the CMZ, the brick and Sagittarius S2, or Sagittarius B2, just a slideshow on them. And it has all the references. But basically what happens, you see how you have that constant background. So that's all the stars on the other side of the CMZ. And then you have the foreground, which is all the stars in between us and the CMZ. And you can see the CMZ just kind of blocks that background light. And it's all the gas and dust soaking up that light. And so you have to try to figure out ways to map the objects within there. You
Okay.
can't just look. You have to deploy a lot of mathematical
You got to
analysis.
interpolate. Yeah.
So if you go to the next, when you lose starlight, that process is called extinction.
Okay.
But extinction doesn't happen to all of the light at once. It happens at specific wavelengths.
Okay.
You understand why?
Certain things are opaque to certain frequencies.
When they're opaque, it means they
Absorb it.
And so they'll absorb it, and then if they get heated enough, they'll release it at other wavelengths.
Okay.
But then some of the other wavelengths continue to get through. As you go through dust clouds or molecular clouds, you're stripping off like one wavelength at a time. You can think of it like a bunch of arrows going through the sky, and some are getting knocked down,
Yeah.
but some are making it. So what you have to do is look for those wavelengths that make it.
Hmm.
And as it turns out, blue light is, the bluer the light is, the more it gets absorbed. So redder light is more likely to make it all the way through the CMZ, right? So maybe you can see that background light, or maybe you can just see light that's absorbed within the CMZ. So this is it's a velocity map of gases within the brick. The brick is not too far from SGRA, and SGRA is cranking out all this radiation. So it heats up the gas within the brick, and I believe the brick is only like 30 light years away, just is not far from that black hole. And if you look on the z-axis, on the vertical axis, you can see that it says kilometers per second.
Yes.
And so what you're actually looking at is, if you look on the bottom, that's the XY axis. So
Yeah.
that's what you would see in front of you. If you were looking at an image of the brick, it looks like a flat postage stamp. And so at the bottom, you can see that dark thing.
The reflection.
That's the image of the brick.
Okay.
And what you have above that is how fast the gas is moving at those different points that you see.
I didn't realize that they were. Oh, and so the faster it goes, the darker it looks.
So that's just kind of this graph. There are some gases in the brick that are going up to 150 kilometers per second.
Okay.
So that if you say 60, that's the equivalent of about 38, 37, 38 miles per hour. Or
Mhm.
I'm sorry, 37 or 38 miles per second.
Mhm.
The speed of sound on Earth is about a fifth of a mile per second.
Right.
So that gives you an idea of how fast the molecular clouds within that brick are just zipping. To say it's supersonic it's an understatement, how fast these are going. I mean, kilometers per
Yeah, it's not even. It's an understatement to say hypersonic.
But the funny thing is, the temperature, even though it's hot, you're talking about temperatures of 50 to 400 Kelvin, right? So you're not even getting to freezing.
400. Yeah,
400 Kelvin? I guess that would be above freezing.
that's
You're right.
boiling.
Is it?
100 Kelvin is C.
That's right.
0 Kelvin is negative 273.15.
That's right. You're right. So you'd be above boiling. As far as like stellar temperatures go, though, it ain't
That
nothing.
is incredibly warm.
For outer
If it
space,
was,
it is. Thank you for correcting me on that. Go ahead to the next.
but 50 to 400, that's such a wild variance.
Well, 50 is still really freaking cold. So if you look at this picture of the brick, you can see that even the black part, the part that's quote black, looks kind of more like a dark brown. You see all this dark brown, and this is a JWST image. So it's in infrared. The JWST is an infrared telescope. It has two different cameras that were used to analyze this. You have NIRCam, which is near infrared camera, and MIRI, mid-infrared, the mid-infrared imager. But you can see, even in all this, you have the dark brown, but you also have, within the black, it looks somewhat reddish.
It's got a little bit of a.
And what that is stellar light. That is the light from stars that is not being completely extinguished as it passes through the brick. This has also had the foreground and background stars removed. So the
Golly, that is some really complex analysis to get it to this point.
and what you're filling in too, you're kind of when you remove that foreground, you're making a guess at what the background would look
Okay.
like. You're kind of making a continuum calculation. So it's possible that behind those foreground stars, you actually have other structures that just aren't entirely visible. Right. If you go to the next slide, so that has the foreground stars removed, and that is the dots are the stars that their analysis estimated are there or located in those positions,
In the background.
or either behind the brick or within the brick itself.
Okay.
Right. But you can see in the center, it's still struggling to,
Yeah, it doesn't see anything.
yeah, it's struggling toward that middle to even pull those out. And this is with the best telescope we have. So that just tells you how much gas and dust is within that brick. It's also known now that gas and dust contains a fair amount of high metallicity, which metallicity within astronomy refers to anything that's heavier than hydrogen and helium.
Right.
And what that means is there had to have been lots and lots of stars and supernovae
Yep.
within that in the past in order for that to have accumulated. And it's funny that it's all still sticking together like that.
Likely to recombine, do you think?
Maybe, but all that radiation that's hitting it, and
Mhm.
it still isn't completely dispersing.
Okay.
So that what that tells me is, I think my conjecture is that there's actually a ton more stars within that than were able to be revealed by JWST, and that they're in there kind of holding that whole thing together. That it's not just this split up diffuse, obviously thicker than what's around it, but still relatively diffuse. You actually have all these stellar bodies that are anchoring it
Right.
together.
You got to have something that's pulling it together.
Right. Like nodes. Yeah. Or like points so where it's sewn. Yeah. So that's the same image with the foreground.
Dude, that's so cool.
The foreground is the stars between us, the
Hmm.
brick. Yeah. If you were going to be like a science fantasy writer, the brick is where the villains would come from.
Mm.
So this is SGRS2, and that's also with NearCam and mirroring. And with NearCam, you can see you can see kind of individual stars. It looks like individual points, right?
Yeah. So correct me if I'm wrong, but the reason we use infrared is because it's the shortest wavelength that really has direction.
That could be. That could be.
Okay.
Yeah, obviously, the tighter the wavelength, the
The
more.
more line of sight.
Right. So JWST was actually built to observe the most distant objects in the universe, right?
Okay.
Which would then be the oldest, but also the youngest,
Okay.
because you're looking back into the past, right? So when you look long distances in the universe, you're also looking into the past.
Okay.
So when it looks at a quasar that's 13 billion light years away,
That happened 13 billion years ago.
right? So that's actually the reason for the infrared on the JWST, but it's incredibly useful for this. And you saw too where it was used to image 3I Atlas, which is actually currently being imaged by all these Mars orbiters from NASA, ESA, and China. It's believed that Perseverance also got a photograph of it.
Oh, really?
Yeah, but I haven't seen the photograph.
Okay.
But I just read that there was one. MIRI is showing all these clouds and other objects, right? And NearCam is showing specific stellar objects. So there's all kinds. Sagittarius S2 is the most active star-forming object in the universe, or in the galaxy. right? At least that we can see. Half of the star forming activity that's going on in the CMZ is happening in Sagittarius S2, right? But the interesting thing is, given the molecular density of the CMZ, there should actually be 4 times as much star forming that's going on. So it's kind of a mystery why exactly it's happening. But some of the objects you'll find in there, that one on the upper left, that's a maser. That's these objects, these specific objects are not in Sagittarius SG2,
Oh,
Sagittarius S2, but they're actually objects that are mostly in other galaxies. But I put them on there so you could see what they would look like on their own. That first one is a maser, it's basically large clouds of molecules that are absorbing light and releasing microwaves. So it's a microwave laser or a microwave spitter outer,
oh,
right? On the right, you have an HII cloud or an H2 cloud, which is basically a whole bunch of superheated ionized hydrogen. But it,
so basically just protons.
right, yeah. And they release all kinds of light. But it's basically hydrogen plasma that is not a star. It's just being superheated by other radiation sources. And then at the bottom, what you have is hot cores. And a hot core in this case, it's not talking about the core of a star. It's talking about basically protostars. So you have a protostar where you don't yet have full-on fusion
Okay.
going on, but you do have the 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 cloud around it, the cloud of material around it that's sweeping in,
Okay.
like a protoplanetary disk, you could say. And when you talk about just like those ionized hydrogen clouds, there's at least 50 of them that have been observed in Sagittarius S2.
Okay.
Just think how big that is. So in addition to all the young stars that are in there, which you saw a bunch of those in near Nearton, you
Yes.
have tons of this other shit that's going on in there. And you can see these wisps in front of it. And then what you have also within it, within the object Sagittarius S2, you have these multiple other stellar clouds, these multiple other molecular clouds within S2 that have been detected. And those molecular clouds themselves can have stars in the middle, but then they're absorbing the light out of those stars. And that heats up those clouds, so you start to get a high velocity of gas within them. And within that gas, you also have high metallicity streams that form within them. So streams of carbon, silicon, oxygen. And what you have is these splotches, like on the lower right, these splotches of light, which is that infrared light escaping through those streams of metallicity within those clouds.
Okay.
Yeah. And this is another object that was suspected to be in there, and it's not entirely 100% certain what it is, but there's 4 other similar ones, what it's believed to be. And those 4 on the left are all planetary nebulae.
Hmm.
They're not actually planets. A planetary nebula is what's left over after a gas giant, after a red giant phase is done. So with a red giant, it isn't just one single phase. So after a star's core has been burning hydrogen for a super long time, all this helium accumulates. And you get too much helium in there for hydrogen fusion to keep going, and the star collapses. It's no longer heated, it collapses. And then it gets hot enough for that helium to start to fuse.
And then that pushes.
So it all pushes it out. And you don't just have this shock wave from all this material hitting. you also have the shock wave from this incredibly high. The fusion of helium is much hotter than fusion of hydrogen, and it pushes it back out, and that helium starts to fuse into carbon. And that carbon, helium to carbon fusion is much hotter. And so it pushes it out, but it doesn't last nearly as long because it's burning so hot. And then after you have a carbon core, it collapses down again, and you have another ricochet while the carbon starts fusing. Carbon and helium starts fusing into oxygen and nitrogen. It becomes really complex, but you can keep on having that cycle go on until you get to iron. And iron, the reason you run out at iron, you have...
The energy to fuse is higher than the energy
Right.
it generates.
When you talk about fission, you can look at fission on this side,
Mhm.
right? The energy to fuse above iron, right, costs more energy than you get out of it. But what's interesting is fission acts the same way. You have uranium over here, right? And you can keep on doing fission on all these atoms until you finally get to iron. And then you actually have to put in more energy to get fission
Oh,
than you would get out of it. Iron is this,
the 0 point.
yeah, it's the trough
Hmm.
for nuclear energy. That's why with planetary nebulae, you get these different layers of ejected material. And that's on the right, that image from Sagittarius S2 is believed to be a planetary nebula. So
Okay.
it wasn't something they were specifically looking for. And it isn't for sure, but it looks like it's there.
Okay.
And I think that's it for our slideshows.
All right.
We're done. Yeah. What are your
Astronomy is so cool, dude. All those images, all the post-processing that they had to do to figure out just what lays beyond. Dude, that is just so incredibly cool, and it looks incredibly complex.
It is. One thing with scientific studies now is there's no simple scientific studies left.
Mhm.
There's no more looking through a telescope with a pencil.
Right.
You know, it's you find these objects, and then you need all this mathematical processing behind it. You're using astrophysics, chemistry, and mathematics, and computer science.
Right.
Like-
Study of light. I don't know what that is, but the study of light as well.
Right. And so it's like all scientific studies have become these collaborative processes where you need all these different people who have these different skills
Right.
to make it work.
Right. Mr. Miyazaki, he's a immunologist, but he got a suggestion from basically someone who studies cholesterol.
Huh. Yeah. So I have enjoyed collaborating with you today.
Yeah.
Dude, thanks for watching us on Everybody's Podcast. Today we talked about,
I thought our first thing was, holy shoot.
we went through our comments.
Yeah.
We talked a little bit more about Nietzsche and the
Yeah.
three hairs.
Yep.
The eternal return.
Yes.
We also talked about the Green Man and how he fits into some biblical legends and mythology. We talked about
Genotype in cats.
and how cats come, well, where cats come from.
Yeah.
And then we looked at
Oh.
Coyote Ugly.
Oh,
and how
okay.
bacteria gnaw off their arm to get away from viruses. And finally, we ended with a discussion of the brick and Sagittarius S2 within the CMZ.
Yeah.
And we are grateful to all of you for being with us today. I believe the ideal life is a nonstop process of learning and growing. Thanks for learning and growing with us. Stay on your game, and we'll see you next time on Everybody's Podcast.
All right.
Good work, man.
Yeah, dude. That was fun.
That was beastie. Wonder how long that was.